Solving Advent of Code Day 4 today. Let's go over the problem statement. Scratch cards. Elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. One of it looks like each card has two lists of numbers separated by a vertical bar. A list of winning numbers and then a list of numbers you have. You organize the information to a table. Your puzzle input, as far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the value of that card. For example, the card 1 has 5 winning numbers, 41, and this thing, or everything to the left of this slash, and 8 numbers you have, 83, all these things. Of the numbers you have, 4 of them are winning numbers, because this lies to the left as well as right. 83 also lies here and here, 86 here, and 17 as well, and 41 does not lie to the right hand side. That means card 1 is worth 8 points. The count multiplied by 2, 1 for the first match, then doubled 3 times for each of the 3 matches. Wait, the first card makes the card worth 1 point in each match after the first doubles the value of that card. Double 3 times for each one. So 2 raised to 3, 8. And if there are n matchings, then 2 raised to n minus 1. 2, right, 2 raised to 0, 1, 2 raised to... Take a sit in the large pile of colorful cards. How many points are there in total? I hope I have understood the points. You have to figure out which of the numbers you have appear in the list of winning numbers. There you discovered all with the public coverings, a list of winning numbers, and then a list of numbers you have. You organize the information into a table. First, there is a list of winning numbers, then is a list of numbers we have, and you have to figure out which of the numbers you have appear in the list of the winning numbers. Okay, for each of them we need to check whether they are appearing in the left hand side. The first match makes the card worth 1 point, and each match after the first doubles the point value of that card. It means card 1. For the first match. 3 times for each of the 3 matches. Okay, fine. Let's do this. I have understood the question. Okay, this number seems to be fixed. This is always 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and something here. But let's try to generalize that. Create day 4. Let's see. Okay, let's start. We need to input the lines. Let's split on space and then do. Should I use Python? Maybe I should. Let's try Python today. Let's take open one. Into okay. First of all, we will split it on this column. How do we take input in Python? We take the line, then let's split it at the colon, then trim it. Then again, now this should return. We want the second slice. After that, we split it again on this character. Let's see what we get. Okay, I think it is a bad idea to use Python. I don't want to unnecessarily waste time today. I will use my template for reading lines. Okay. I want to split it. Let's get the words. Do I have new implementation for that already? Yes. This is first, this is second, third, fourth, and so on. Let's start from index 0, 1, 2 and go until this character is encountered. Let's store them as integers. First and second. ID is 2, while ID is less than int, word start size. And that word is not equals to a symbol. Let's do one more thing. Also push back the integer value of that. Fine. I can assert that this is this. Let's start from ID plus 1. This time push the values in second. And no need to check this condition now. Let's try to print these numbers and see if we have found the correct ones. This should be this character, right? Answer for this is 13. Let's say it is 0 for now. Why is it starting at 0? Only contains this character. This should be get line, scene line, right? And then let's check. Okay, there is a comma as well, or not? No comma. Still, it's wrong. Okay, there are multiple spaces. This should handle that. Let's check. Okay, at least not an runtime error. So we have this. Let's go over them. We need to go over all the values y in second. If it is present, let's say point is initialized with 0 first. If it is present in the first, let's say first dot begin, first dot end, y is greater than 0. If points is 0 initially, points become 1, else points multiplied by 2. And this is for this particular case, and answer is sum of all points. Let's check. 13. Okay, at least the first case is giving 13, and last is this. Hope this is correct. Perfect. Let's go to part 2. Let's remove the debug statements. Perfect. Let's copy this. Just as you are about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There is no such thing as points. Instead, scratch cards only cause you to win more scratch card equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card equal to the number of matches. So cards if card 10 were to have 5 matching numbers, you would win one copy each of cards 11 to 15. Copies of the scratch cards are scored like no scratch card and have the same card number as the card. This is too confusing. So if you win a copy and it has 5 matching numbers, then it would win a copy of the same cards. None of the copies cause it win any more cards. Cards will never make you copy differently. Card 1 has 4 matching numbers. Oh, okay. Card 1 is one case actually, right. So, yeah. Card 1 has 4 matching numbers. Is it the same input? Right, so 83, 86, 83, 86, 17, 48. So you win one copy each of the next 4 cards. 2, 3, 4, and okay. 1 plus the number of matchings. And you win one copy each of the next 4 cards. Your original card 2 has 2 matching numbers. So you win one copy of each 3 and 4. Fine. A copy of card 2 also wins one copy each of cards 3 and 4. There are 4 instances. Card 3 have 2 matching numbers, so you will win 4 copies each of this. Okay. So we start with 1. We find out this range L2R, increment the counter for all of them by 1. Initially card 1 has counter equals to 1. Initially for all of this the counter is equals to 1, and after this card is processed we find out this range L2R, add 1 to all of their counters, and if this line is completed then we start the iteration from this line, and its total count will be 1 plus the counters that we added in the previous iterations. Once all of the original cards and copies have been processed, you then end up with 1 instance of card 1, 2 instances of card 2, 4, okay, some instances of each of them. In total, this example pile of scratch cards causes you to ultimately have, okay, so sum of all this 22, 23, 27, 29, 30. Process all of the original and copy until no more scratch cards are won, including the original set of how many. Okay, fine. Let's start. Line ID is 1 initially, and let's say map of map is not needed. Let's use some simple array. Let's initialize all of them with 1, or is it necessary or not? That's not necessary. We can simply add 1 while taking the count. So here we don't find out the points, we just find out the number of pairs, right? So this pairs is this. Now the L was line ID plus 1, and R was, let's say, 1, 2, line ID is 1 and 4 matches, then line ID plus pairs, and we need to add. Let's do it naively. If it slows down, then we can optimize it using prefixes. And after this, what is the issue? Fine. Answer plus equals to count of this line ID. It should be plus 1. Now need of this plus 1, and line ID plus 1, obviously, right? The answer for this was 30. Your answer is 15. Okay, so if we are not going to increment it by 1 but self count here would be this thing. This is the count of items of this line number, and this many times it should be incremented, because for each of them it will add plus 1, so in total it will add these many number of times. Where is the debug statement? Why was it printing a lot of things in between? It was printing something. Okay, first test seems to be correct. Let's try this output. Okay, looks correct. Okay, that's it. Let's commit this solution. Nothing to refactor as such. Copy sol.cpp to sol part 2.cpp. remove all these files. Okay. The first one and the second one. Fine. That's it. I'm closing the stream. Thank you. Thank you for watching.